The factor theorem states that x minus a is a factor of a polynomial if and only if the value a is a zero of a polynomial function. So this if and only if statement you might remember from geometry is called the biconditional. So you can also read it backwards. So if the value a is a zero of a polynomial function, then x minus a is a factor. So look at the graph of x squared plus 3x minus 4 at right. So here's this graph of this quadratic, which is a parabola. So -4 is a zero of x squared plus 3x minus 4 equals 0. So it's a solution to that equation. -4 is an x-intercept. It's an x-intercept of the graph because it's crossing the x-axis. And then x plus 4 is a factor. So besides -4, what else is a zero? So the zero is where it crosses, so the zero is also 1. So x equals 1 is a zero, or you can also write just 1. What is another x-intercept? Well, another x-intercept is going to be at 1, or you could write it as 1, 0 as an ordered pair. So what's another factor? So if 1 is a 0, then x minus 1 is going to be a factor. So give the zeros of each of the following. So these are already factored out. So if you set this equal to 0 and use the zero product property, the zeros are going to be 3 and -4. Because if you set x minus 3 equal to 0, x is 3, and x is -4. And so if you set each one of these equal to 0, the zeros are going to be -5, 7, and -2. And then C, if you set this equal to 0, don't forget to set the x equal to 0 on the outside because that's a factor. The zeros are going to be 0 and +6. So sometimes you might be thinking, oh, just take the opposite of the number. But if you had something that was like y equals 2x plus 1 times x, or 3x plus 2, your zeros would not be -1 and -2. You'd actually have to do 2x plus 1 equals 0 and solve for x, so x would actually be -1/2. Then you'd have to do 3x plus 2 equals 0 and solve for x, so x is -2/3. Okay, multiplicity. A repeated 0 is called a multiple 0, in which we use the word multiplicity. So this multiplicity means a factor repeats. So find the zeros of this function and state the multiplicities. So first of all, what is the degree of y? So the degree of y is going to be, you have x cubed plus, there's going to be 3 zeros here, plus 2 zeros here, plus 4 zeros here. So the degree is going to be 4 plus 2 plus 3. So the degree is going to be degree 9. So the degree, let's look at this 0 first. So that 0, if you set 3x cubed equal to 0, you're going to get 0. So 0 has a multiplicity of 3 because that's a degree. If you set x plus 2 equal to 0, the 0 would be -2, and the multiplicity is 2 because that's a degree. And then x minus 7 equal to 0, the 0 would be 7, and the multiplicity would be 4. So number 2, find the zeros and state their multiplicities. So what's the degree of y? Well, this is going to be degree 1. At 2x, so you're going to have degree 1. You're going to have 1 0 plus 2 zeros, so it's going to be degree 3. So 2x, you set 2x equal to 0, so the degree 0 has a multiplicity of 1. And the 0 at -3 does, oops, I think I did that the way around. I should have did So multiplicity of 1 is not really, it's not more than 1. So it wouldn't be called a multiplicity. So I would write -3 has a multiplicity of 2, and the 0 at 0 does not have a multiple 0. Okay, 3, write this in standard form. So standard form means that you don't have parentheses. So remember, you can take the first 2 and distribute. So it's going to be x squared plus 2x. I'm going to hold that in parentheses and multiply it by x minus 3 in FOIL. So this is going to be equal to x cubed, because x squared times x cubed, or x is x cubed, minus 3x squared plus 2x squared, and then minus 6x. So it's going to be y equals, so standard form means write it in highest to lowest degree. So it's going to be x cubed, and then negative 3x squared plus 2x squared is negative x squared, and then minus 6x. Okay, 4, write this in standard form. So I'm going to actually multiply these two first. So that's going to be y equals x cubed, because x squared times x is x cubed, minus 5x squared. Keep this in parentheses and multiply it by x plus 1. Okay, then I'm going to FOIL this. So it's going to be x to the 4th, because x cubed times x is x to the 4th, plus x cubed minus 5x cubed, and then minus 5x squared. So when I put it all together, it's going to be y equals x to the 4th, x cubed minus 5x cubed is negative 4x cubed, and then minus 5x squared. Okay, number 3, find the zeros and graph the function, then find the relative min and max. So first I'm going to write the zeros. So the zeros are going to be at -1, 1, and -3. So you can actually plot those, -1, 1, and -3. So this is where it's going to be crossing the x-axis. Then find the relative min and max. So I'm actually going to put this in my y1. So go to y1 in your graphing calculator and type in x plus 1, x minus 1, and x plus 3. So I'm going to press pause and put that in my calculator. So I put that in my calculator, and I'm going to get specific values when I graph it. So I'm going to go to my table, and my y-intercept is going to be at -3. So I look at where x is 0, y is -3, so that's another point. And then to get the other points, I'm going to use my relative min and max. So I also see -2, 3 is on there. So relative min, so on a graph, a relative min would be the lowest y value. So this graph, this function is going infinitely to the left and right, so it doesn't have a max or a min per se. That's why we call it a relative min or relative max. So within this boundary, this is the lowest part. So this would be your relative min, and this would be your relative max. And we're talking about y values. So to find the relative min max, you're going to do second trace min max on your graphing calculator. So I'm going to link a video on how to do that. And right now I'm going to find my relative min max. So I'm going to draw a rough sketch of this graph right now, just so I can kind of point out the relative min and max. So on this one, this would be the relative max, and this would be the relative min. So what I do is I go to second trace minimum. I'm going to do the minimum first. So right here, this is the minimum down here, someplace around here. So your cursor is blinking. I'm going to make my cursor, the question reads on your graphing calculator left bound. So I'm going to, if this is my minimum value, I'm going to get right to the left of it. So I'm going to go right here and press enter. And then I'm going to go on the right hand side of this minimum. So I'm going to get someplace over here on the other side of this point and press enter. And then when it says guess, just press enter again. So the minimum value, I just want the y value. So the minimum value to the nearest hundredth is -1 oops, I put it in the wrong spot, negative 3.08. So the relative maximum, I'm going to do second trace again, maximum. And my relative max is up here. So I want to get on the left-hand side. I want to get my cursor to be on the left-hand side of this. So I'm going to press enter first over here, just on the left-hand side. And then it asks me for the right-hand side, which would be just over here. To make it less complicated, just get close to this. A lot of people get confused because they go all the way over here. Just go right to the right, left, right to the right, and then press enter on your guess, and you'll have fewer problems. So the relative max is the y value, it's positive 3.08. Now, they're not always opposites like that. It just so happens with this function it is. So the relative min and max, you want the y values. So I'm going to do another example of here. Find the zeros. So the zeros are going to be at 0, positive 2, and negative 1. So I'm going to write the zeros in 0, positive 2, negative 1. I put this in my y equals, so I put x, y1, x plus 2, x minus 1, or x plus 1. Actually, it's x minus 2. I think I might erase that. Let's see. Yeah, x minus 2, and then x plus 1. Hit graph. So I would go to my table and get better points, but for the purpose of doing this, I'm going to graph it like this. And then I'm going to find my relative max, which would be right here, and my relative min, which would be right here. So I'm going to put those in. So I found those by getting on the left and the right-hand side of it, and I'll link up a video. So number 5, write a polynomial with these zeros in factored form. So it's going to be y equals, if negative 4 is a 0, it's going to be x plus 4. If negative 2 is a 0, it's going to be x plus 2. And if 1 is a 0, it's going to be x minus 1. Okay, number 6, write a polynomial that has zeros at negative 5. So it's going to be x plus 5. 0, so it's going to be just times x. And then 2, so it's going to be x minus 2, and then 6, so it's going to be x minus 6.